plus b equals 1 and a squared. Can you solve this math challenge? Here's the question. Solve for the value of a raised to 11 plus b raised to 11, given that a plus b equals 1 and a squared plus b squared equals 2. Now you can pause this video if you want to give this problem a try. And now, let's answer this question together. So, given these two equations, a plus b equals 1 and a squared plus b squared equals 2, then our main goal is to solve for the numerical value of a raised to 11 plus b raised to 11. Now, I provide two solutions for this kind of question. So the first one, let's have the algebra approach. And the second one, the Newton's sum. So you can use algebra alone, you can use Newton's sum alone, or you can use both of them at the same time. Alright, so let's begin with our first method, which is solving the value of this a raised to 11 plus b raised to 11 using algebra. Okay, let's begin. First, let's get the first equation, a plus b equals 1. Now, what we're going to do is to square on both sides. And take note, when we expand a plus b raised to the power of 2, we get a squared plus 2ab plus b squared. Now, 1 raised to the power of 2, we know that this is just 1. Now, let's rearrange some terms a little bit. So, we have here 2ab plus a squared plus b squared. Now, why we do that? Because we know the value of a squared plus b squared. This is also given, and this is just 2. So we can replace a squared plus b squared with 2. Now, let's solve for the value of a times b. So let's subtract 2 on both sides, and if we do that, we get 2ab equals 1 minus 2, and 1 minus 2, this is just negative 1. Now, divide both sides by 2, we get that the product of a and b must be equal to negative 1/2. Now, this is very important in our solution. Next, let's get these two equations and let's multiply them. The purpose is to get the value of a cubed plus b cubed. Now, let's do that. Now, let's simplify. 1 times 2, this will give us 2. And if we multiply a plus b multiplied by a squared plus b squared, you get something like a cubed plus ab squared plus a squared b plus b cubed. Now, this is very important, the a cubed plus b cubed. So, let's rearrange some terms a little bit. Now, in these two terms, let's factor out a times b. If we do that, we get ab multiplied by a plus b. Now, we have a value for a times b. This is negative 1/2. And we have also a numerical value for a plus b, which is given, and it is 1. So we can replace ab with negative 1/2, and this a plus b with 1. Now, let's simplify. Negative 1/2 times 1, this is just negative 1/2, of course. Now, add 1/2 on both sides to get the value of a cubed plus b cubed. And we have 2 plus 1 over 2. And 2 plus 1 over 2, this will give us 5 over 2. Now, we have the value for a cubed plus b cubed. Alright. Next, let's get the second and the third equation. Now, our purpose is to multiply them again. And in this case, we can now find the value of a raised to the 5th power plus b raised to the 5th power. But before that, let's simplify first. 2 times 5 over 2, this will give us 5. And if we multiply the left-hand side of our equation, this will give us a raised to the 5th power. This is what we want, and b raised to the 5th power. So plus a squared b cubed plus a cubed b squared. Now, let's rearrange some terms a little bit again. And from these two terms, let's factor out a squared b squared. And if we do that, we get a squared times b squared multiplied by a plus b. Now, take note that a plus b, this is given, is already equal to 1. So, we can replace this with 1 later on. But take note that a squared times b squared, this can be written as follows. We have ab raised to the power of 2. Now, we know a plus b is 1, and a times b is just negative 1/2. A times b is negative 1/2. Now let's simplify. Negative 1 over 2 raised to the power of 2. This will give us 1 over 4. Now subtract 1/4 on both sides. And 5 minus 1/4, this will give us 19 over 4. This is now the numerical value of a raised to the 5th power plus b raised to the 5th power. Alright. Next, let's get the third equation. And what we're going to do here is to square this equation. But the purpose is to get the value of a raised to the 6th power plus b raised to the 6th power. Now, let's simplify a cubed plus b cubed raised to the power of 2. If we do that, we get a raised to the 6th power plus b raised to the 6th power plus 2 times a cubed b cubed. And on the right hand side, we have 5 over 2 raised to the power of 2. Now, simplifying this, we get 25 over 4. Now, a cubed times b cubed, this can be written as a times b raised to the power of 3. Now, we know the value of a times b. This is again negative 1/2. So we can replace this with negative 1/2. Now let's simplify. Negative 1/2 raised to the power of 3. This is just negative 1 over 8. And 2 times negative 1 over 8. This will give us negative 1/4. Now add 1/4 on both sides. This will give us a raised to 6 power plus b raised to 6 equals 25 over 4 plus 1 over 4. And 25 over 4 plus 1 over 4, this will give us 26 over 4. Now, we can simplify this. We can divide the numerator by 2 and the denominator by 2. And if you do that, you get 13 over 2. That is the numerical value of a raised to the 6th power plus b raised to the 6th power. Now, we are almost done because if we multiply a raised to the 5th power and a raised to the 6th power, you get a raised to 11th power. So what we're going to do here is to multiply these two equations. Now, if we multiply a raised to the 5th power plus b raised to the 5th power times a raised to the 6th power plus b raised to the 6th power, you get something like a raised to 11 plus a raised to the 6th power times b raised to the 5th power plus a raised to the 5th power times b raised to the 6th power plus b raised to the 11th power. And this is what we want. Now, let's simplify first the right-hand side of our equation. 19 over 4 times 13 over 2, this will give us 247 over 8. Now, on the left side of our equation, let's rearrange some terms a little bit. From these two terms, let's factor out a raised to the 5th power times b raised to the 5th power. And we have a raised to the 5th power times b raised to the 5th power times a plus b. Now, we know a plus b is given, which is 1. So we can replace this with 1. And a raised to the 5th power times b raised to the 5th power, we can rewrite this as ab raised to the 5th power. Now, we know a times b, this is again negative 1/2. Now, negative 1/2 raised to the 5th power, or negative 1/2 times negative 1/2 times negative 1/2 5 times, you get negative 1 over 32. Now, add 1 over 32 on both sides, and we get 247 over 8 plus 1 over 32. Now, take note, the denominator is not the same, so why not multiply 247 over 8 by 4 over 4? Because we know 4 over 4 is just 1, alright? Now, the numerator now becomes 988, and the denominator becomes 32. Now, since we have the same denominator, we can now add them. So, 988 plus 1, this will give us 989. And all over 32, the denominator 32. And that is the numerical value of a raised to 11 plus b raised to 11. And that is the answer using algebra. Alright, so now, the next question is, how about the Newton sum? So do we get the same result? And of course, we get the same result. So now, let's find out how do we use Newton sum to answer